In this video, I'll talk about form tolerance straightness, what it means, how it's used on technical drawings, and I'll walk you through a few real examples to make it clear. In geometric dimensioning and tolerancing, straightness is one of the four types of form controls. Straightness can control the line element of a surface whether the part is rectangular, cylindrical, or conical. It can also control the straightness of a derived median line on a cylindrical feature. These two types of straightness have very different meanings, but fortunately they're clearly distinguished on technical drawings by how the feature control frame is applied. Surface straightness is a two-dimensional tolerance used to verify that a surface or feature remains consistent and doesn't deviate in a straight line. It can be applied to a flat surface like the face of a block or to the surface of a cylinder running along its axis. Essentially, it defines how much variation is allowed along a specific line on that surface. On technical drawings, straightness is indicated directly on the surface being controlled. To inspect it, a dial gauge scans along a straight line. The variation in readings reveals how much the surface deviates, showing how straight or how uneven that line actually is. The other form of straightness is derived median line straightness. It applies to axial features, such as cylindrical shafts or holes. Instead of controlling the straightness of the surface itself, it controls the straightness of the center line that runs through the feature's length. In practice, this tolerance ensures that the part's central axis does not curve as it extends. For example, a long shaft might have a perfectly round cross-section but still be slightly bent overall. Derived median line straightness limits that bend. The tolerance zone for this type of straightness consists of two parallel lines, spaced by the specified tolerance value, within which the entire derived median line must lie. This is especially important for rotating parts, bearings, and precision assemblies, where any deviation in the axis could cause vibration, misalignment, or uneven wear. On a drawing, axis straightness is called out next to the size dimension of the axis, and to gauge axis straightness effectively, the MMC modifier is sometimes called out on the drawing. To ensure that a part or feature is axially straight, a cylinder gauge is used to determine if the part fits in its total envelope at MMC. This controls the combined effect of the diameter and of the axial straightness. The ID of the cylinder gauge represents the maximum virtual condition of the part. So, straightness tolerance ensures features stay true to their intended form. Thanks for watching, and if you find this video helpful, please like and subscribe.